Okay, then some answers to the second sheet of revision questions. So question 1 gives you that a map scale is 1 to 400,000. It says on the map, the distance between two towns is 7.2 centimetres. Find the actual distance between the two towns. So we're going to do 400,000 times 7.2, and I get 288,000. So that's how many centimetres it is between the two towns. Now, if I want to change that into metres, I'm going to divide by 100. So if I divide by 100, I get 288,000 metres. And then I'm going to divide by 1,000 to change it into kilometres. So I get 28.8 kilometres for one part A. And then one part B says, find the distance apart on the map of two towns that are actually 100 kilometres apart. So let's work out what that is in metres. So to change that to metres, I'm going to times by 1,000. And then to change that into centimetres, I'm going to times by 100. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7 zeros in centimetres. So if I know that 1 centimetre goes to 400,000 centimetres, I'm trying to work out how many centimetres will go to 10 million centimetres. So I want to know what I've times that by. So if I do 10 million divided by 400,000, I get 25. If I times that side by 25, I'll get 25 centimetres. So for this one, the distance on the map is 25 centimetres apart. Okay, question 2 is just asking us to put these ratios in the form 1 to n. So part A is 1 centimetre to 10 metres. So that's the same as 1 centimetre. To change metre to centimetres, we need to times by 100. So that's going to be 1,000 centimetres. So the first one is just 1 to 1,000. For part B, it says 1 centimetre to 2 kilometres. Well, that's the same as 1 centimetre to 2,000 metres. And if we change that into centimetres, times by 100, so it's 1 to 200,000 for the second one. Okay, part C then is 1 centimetre to 40 kilometres. So if we times by 1,000, that changes it to metres. And if I now times it by 100, that changes it to centimetres. So this time it's 1 to, that's 4 million for that one. D is 2 centimetres to 10 metres. So that's the same as 2 centimetres to, if I change metres to centimetres, I'll times by 100. It's 1,000 centimetres. So my ratio is 2 to 1,000, but I want it in the form 1 to something. That's 1 to 500 for that one. E, 5 centimetres to 2 kilometres. So that's the same as 5 centimetres to times by 1,000 to change it to metres. And then times by 100 to change it to centimetres. So I've got 5 to 200,000. And then to change that to 1 to something, we divide by 5. So it's 40,000 for that one. And lastly, part F was change 4 centimetres represents 10 kilometres. So 4 centimetres will represent times by 1,000 for metres, then times by 100 for centimetres. So it's 4 to 1 million. And if I want to make that 1, I'll divide by 4. So that'll be 250,000. So 1 to 250,000 for that one. Okay, question 3 then is the currency in Ethiopia is the birr, so £1 is 48 birr. So remember we said if we're then converting pounds to birrs, we times by 48, and if we're converting the other way, we divide by 48. So for the first one, how many birr can you buy for £50? So I'll do 50 times 48. That gives me 2,400. Next one I'll do 80 times 48. That gives me 3,840. And the last one's 2,000 times 48, which is 96,000 for that one. And the second one, how many pounds can you buy with birrs? This time we're going to do the dividing by 48. So 9,600 divided by 48. That one's £200. Next one, 12,000 divided by 48 is £250. And the last one, 240 divided by 48 is £5. Okay, there was one of these on the last one where we do the gradients of the lines. So we said the gradient of the line was that we got, if we drew a little triangle, we worked out the distance of each. So for this A, we've got 1, 2, 3, 4, 5 along the bottom, 3, 4, 5 on the sides. Remember, it was the 5 on the bottom to the 5 at the side. So the ratio is 1 to 1. So for the first one, the gradient is 1. So for line A, the gradient is 1. I'm just going to rub out this so it's out of our way. If I do B, so in B, if I do the same little thing, this is 2 and that's 3. So the ratio is 2 to 3, or 1 to 3 over 2, or 1 to 1.5. So for that one, the gradient's 1.5. So we get the gradient to 1 dot dot something, and the thing on the other side is your gradient, isn't it? So C, that's 3 to 1. And the gradient will be, or the ratio is 3 to 1, divide by 3, 1 to a third. So the gradient for C is a third. For D, I've got 2 there, and I've got 1, 2, 3, 4, 5 there. So the ratio is 2 to 5, divide by 2, it's 1 to 2.5. So for this one, the gradient is 2.5. And for E, the last one, if I measure on the bottom, I've got 1, 2, 3, 4, 5, 6. And this is 1. Oops, not 6. 6 and 1. So the ratio is 6 to 1. If I divide by 6, that's 1 to 1/6. So the gradient is just 1/6 for that one. And the last one here in the sheet's easy. You've got the formula C equals pi d. So for this one, the d is diameter across, so circumference will just be pi times 21. So on my calculator, I'm going to do pi times 21. And it says give your answer to the nearest integer. So my calculator is giving 65.973. So the nearest integer means the nearest whole number. So my answer here is going to be 66. That's the nearest whole number to 65.93. Next one is going to be pi times 226. If I do pi times 226, my calculator gives me 709.9999397. So to the nearest integer, that's 710. That would round up to. And for the last one, C equals pi times 56. So my calculator, I'm going to do pi times 56, and I get 175.929. Nearest whole number, that's 176 millimeters for that one.